This week, we have been looking at the characteristics of the graph of a quadratic function of the form f of x is equal to ax squared. We started with a table of values, and we used those ordered pairs to come up with the graph of the parent quadratic function. Using decimals to come up with the table and the graph, we have a table of values here with x values from -3 to +3 and with y values from 0 through 9. How would you describe the rate of change in the table of values? So if you notice, the values increase by adding 1, 3, and 5. So under the x column, the x values are increasing by a constant rate, which is adding 1 each time. However, under the y column, the increase is described by 1, 3, 5. However, if you look at the differences between any two numbers, 1 to 3 has 2 as a difference, and then 3 to 5 also differ by 2. So in a quadratic function, the first order differences are not the same, but the second order difference is constant, which is 2. Now let's look at the graph. You may think of this as the slope from one point to another. Let's say up 1, right 1, so the slope there is 1. Up 3 over 1, the slope is 3. And then up 5 over 1, the slope or rate of change is 5. So in the parent function where a is equal to 1, we saw a pattern, 1, 3, 5. So why is this shortcut useful? Even without making a table of values, if you know the vertex of your parabola, you can count using this pattern. Let's say up 1, 1 over, you'll get the first point after the vertex. And then up 3 over 1, you'll get another point, and so on. And since we know that the parabola is symmetric with respect to the x-axis, you can just reflect those points across the y-axis. So that's one way of creating the graph. One common misconception is when you are squaring a negative number, do you get a negative or a positive answer? So when you multiply -2 by itself, -2 times -2 is +4. Similarly, -1 times -1 is equal to +1. So if your values do not repeat with respect to the vertex, which is normally the middle portion of your table, then you know that you have to go back and revise some of your values. Now looking at the graph, if you revise these values, definitely that will change the shape of the ordered pairs here if you connect them. The graph of a quadratic function is a parabola that is facing upward if the value of a is positive. And if we change the value of a to a negative number, the parabola will face downward. The next thing we're going to look at are some items that show how quadratic functions model real-life scenarios. In this figure, you have a satellite dish with x and y being measured in meters, and we're supposed to find the width and depth of the satellite dish. If you look at the figure, the domain of your parabola is from -2 to +2. Normally, we say the domain of a quadratic function is all real numbers. However, in this image, it's cut from -2 on the left to +2 on the right. So that means if you find the width of your parabola, you get the distance from -2 to +4, and that will give you 4 meters. On the other hand, let's use the range to find the depth. So starting from the vertex, your highest point here is y is equal to 1. So if you find the distance from the vertex to the highest point, it's equal to 1 meter. So the depth of the dish is 1 meter. So the satellite dish is 4 meters wide and 1 meter deep. So now give yourself some time to try this on your own. Pause the video, try it out, and then I'll reveal the answer later. Pause it now. Okay, I hope you gave it a try before we reveal the answer. So using your domain here, which is from -2 to +2, the width of your spotlight will be 4 inches. Then how do you find the depth of the spotlight? Well, you can do this in 2 ways. You can graph y is equal to 0.5 x squared over the values given for its domain, and then you find the distance from the vertex to the highest points of your graph. So that will give you y is equal to 2. So that means if you get the distance from 0, which is the vertex, to the highest point, then the depth will be 2 inches. Okay, so those are just some applications of graphing quadratic functions.